Question 12f. Use mathematical induction to prove that 15 to the power of n plus 6 to the power of 2n plus 1 is divisible by 7 for all integers n greater than or equal to 0. The first step is to show that the statement is true for the base case n equals 0. Substituting n equals 0 into the statement, we have 15 to the power of 0 plus 6 to the power of 2 times 0 plus 1 equals 1 plus 6 equals 7, which is divisible by 7. Hence the statement is true for the base case n equals 0. The next step is to assume that the statement is true for n equals k, where k is an integer greater than or equal to 0. So 15 to the power of k plus 6 to the power of 2k plus 1 equals 7a, where a is an integer. Rearranging the assumption to make 15 to the power of k the subject, we get 15 to the power of k equals 7a minus 6 to the power of 2k plus 1. The next step is to show that the statement is true for n equals k plus 1. So 15 to the power of k plus 1 plus 6 to the power of 2 outside of k plus 1 plus 1 is equal to 15 times 15 to the power of k plus 6 to the power of 2k plus 3, which equals 15 times 7a minus 6 to the power of 2k plus 1 in brackets plus 36 times 6 to the power of 2k plus 1. And this is from the assumption. Which equals 15 times 7a minus 15 times 6 to the power of 2k plus 1 plus 36 times 6 to the power of 2k plus 1. Collecting these two like terms, that equals 15 times 7a plus 21 times 6 to the power of 2k plus 1. Factorising out 7 from both of these terms, that equals 7 outside of 15a plus 3 times 6 to the power of 2k plus 1, which is divisible by 7 since 15a plus 3 times 6 to the power of 2k plus 1 is an integer. Therefore, by the principle of mathematical induction, the statement is true for all integers n greater than or equal to 0.